First one is Diogo Cunha, who's going to talk to us about something which I'm going to find very interesting myself, which is ray tracing. So I think there might even be a little bit of physics involved in this, maybe?
A little bit.
A little bit?
Math, a little bit.
Okay, a bit of math and a bit of physics involved in that. So I'm really looking forward to this one. So I will actually start talking, get out of the way, and let you get on with it.
Thank you. Thank you. So hello, my name is Diogo Cunha. I'm a full stack developer from Lisbon, and I'm working here in Dublin. And today I'm going to talk about ray tracing using a distributed browser-based platform. Let's see what that means. So basically, what I'm talking about is about 3D rendering. There's a huge need for 3D rendering amongst various industries. For instance, if we think about the animation movie industry, they use rendering technologies to render their movies. But there's a slightly little problem with that. For instance, if you take the Cars 2 movie, which was made in 2011, the normal time to render one single frame is about 11.5 hours, which is like incredible. Basically, that means that if we count as 25 frames per second, which is kind of the average for a normal movie, a 30-minute movie would be 45,000 frames. Meaning a lot of hours, a lot of days, basically 5 months of 24/7 rendering, which is amazing, and just for a 30-minute movie. So one approach to solve that problem could be ray tracing using a distributed browser-based platform, but what the hell does that mean, right? So I'm going to split it in 3 different parts, and we're going to start talking about ray tracing. So ray tracing is a technique used in computer graphics to generate photorealistic images by tracing the path of light through a virtual scene. And because it simulates the path of light, it's possible to reproduce a wide variety of optical effects such as reflection, refraction, scattering, and dispersion. Well, amongst others. But the fact that we can reproduce these effects dramatically increases the realism of the render when compared to other rendering techniques. Alright, so for instance, this is an example of a ray tracing render done with a high level of realism, as you can see. But the question is, how does it work? So the basic principle behind ray tracing is, as I said, is to cast rays of light from the camera to the objects in the scene. Anytime the ray intercepts an object, it will be reflected according to the physical models of those optical effects that I mentioned before, and they will sort of generate a reflection ray. Basically what happens is that for each reflection, so for instance that ray goes to that circle over there, which might be a sphere, and then it's reflected based on some physical properties. You might hit another object, and it will be like reflecting between objects a specified amount of times. So we can specify the number of reflections that we want. Eventually that ray will hit a light source. And when does that, when that happens, basically we're going to start moving backwards in the process. So based on the properties of the light source, for instance, the color or other stuff, we can go back on that path that the light made, and based on the, as I said, for instance, the color of the light source, but as well the properties of the objects where the beam intercepts. For instance, the material of the object. For instance, that sphere could be some sort of metal, or could be some sort of plastic, or some sort of glass, for instance, which have different properties that will basically change the way the color, change the color of that beam. So going back through the camera, if we kind of put a virtual grid in between the camera and the object scene, that light ray will intercept one of those cells in that grid. And basically, if we take the whole grid as a picture, each one of those cells corresponds to a pixel. So basically what happens is that at the end we will have a full image of the full path of that ray. So the question is, how hard is that? Well, it's very hard. In terms of CPU, It's really hard, sorry. And GPUs can really help generally. Why? Because we are calculating interceptions between lines and three-dimensional objects, which have a lot of equations to solve. So we can take a simple example, and this is probably the simplest one. If we consider, sorry for the math, if we consider an equation of a sphere with a radius r and center in C, and if this is just a normal line array starting in S with a direction D, we calculate the interception using, like we get to that, right? And if we try to solve this thing using a small substitution, we get to that crazy formula. So basically, as you can see, it's not trivial, and this is just for one ray before at the intersection. So, for instance, if the ray hits an object and then it intersects something, it reflects and goes to intercept another thing again, you have to do all the math again. So basically, it's really calculation intensive. The problem is that GPUs, basically, they are like machines that can perform massively parallel matrix multiplication, for instance, 3D transformations, and that's the reason why we use them on our computers to run games and other sort of 3D stuff. And they make transformations to the 3D world to a 2D world, which is our screen. Our screen is just 2D, right? So the problem is that most techniques that are used for games and for other stuff that we use on a computer use a different sort of technique, not ray tracing. And those techniques, usually they make the color placement, so basically they figure out the color of each pixel in a different way. They do it when they already have a 2D projection of that scene, so they don't have depth. So you kind of have to make lots of hacks to kind of really understand what is the color of the pixel. But on the other hand, it's way faster, but you get like results that are not as realistic as with ray tracing. So that's what we really need to, if we want to make an image using ray tracing. Well, basically we're going to need two things. First, a description of the scene. For instance, I have this small piece of code. It defines some sort of configuration first, basically specifying the, the sizes of the image and stuff. Then we say that the camera is going to be on that -200 coordinates. And then I have a plane with a color and with a reflection index and with some coordinates as well. So I will need a file describing all the objects that I have in the scene, spheres, cylinders, planes, whatever. And I will need a ray tracing engine. And the combination of those two things will generate the actual image.
And eyes means the
Sorry?
user eyes, or what?
No, eye is just for the camera. It's just the name was picked
My
for it.
eye.
Yeah, exactly. So, well, there are a couple of standards, let's say, for this sort of description of scenes, but usually they are associated with specific software for rendering. We can find like ray tracing engines usually in software for movie production or 3D CAD modeling software. Usually they come bundled with some sort of ray tracing engine, and they have their own way to describe the scene. So now I'm going to talk a little bit about the second part, which is the distributed platform. Right? What the hell is that? That's easy, I guess. So basically, well, let's see a distributed platform or distributed system, the way you want it, as a bunch of computers connected together, and in this case, we have one which is a coordinator, right? So it's someone that is coordinating a bunch of nodes. So they are able to run a piece of software in a distributed way, meaning that each one of them is going to run part of that software, right? But they are able to communicate with each other. In this case, they use the coordinator to communicate with each other. So if we assume that the system is capable of taking tasks, distribute those tasks amongst the nodes, gather all the results and generate one single result, we sort of have kind of a parallel processing here. And this is what I want to talk about. Well, of course, with this configuration, I obviously can run stuff faster because I'm running in parallel, meaning that if we compare one single node running one program, and if I have 4 nodes in parallel running the same program, this is kind of hard to say how much is going to be fast because it depends on the program itself, but we can see that if it's totally parallelizable, we can have like 4-time speed up. And the question is, can we actually do the ray tracing in parallel? Well, yes, and it's not that hard. So for instance, if we consider the image that we had before, which is big, we can split it up in small chunks, in this case 16. So basically what I'm saying is that we are using a divide to conquer approach to be able to render the image splitting up in small pieces and running them in parallel because they are totally independent. number 1 doesn't need to know anything about number 11 because they're different things. They're nothing connected to them, so they can run separately. Yeah?
You said that nothing connects them, but the arrays are leaving each one of the little squares, because that's the I for each one.
No, in this case it's different. This is, inside this thing you will have lots of pixels.
Yes.
And each individual pixel is the kind of the unit of computation. So you have to do one pixel at a time.
What about reflections that may come from other places? Are they, don't they affect that one?
Yeah, they have effect, but the thing is that you will calculate each pixel individually. So you can really take advantage of stuff that you did before to compute a different pixel. So for each pixel you will send an array and see all the way through and then have the result. And for the pixel next to it, you're going to do the same thing. It's going to be very similar, but it's going to be a whole new computation from scratch. You see, so as I said, you can even compute like individually pixels and they don't have any sort of connection between them. Alright, so the browser base is missing here. It's part of the name, but what does it mean? So if you consider again the distributed configuration that we have, let's say that the nodes, instead of being nodes, as we said, are now web browsers. And we can assume, because we know that there are a lot of browsers in the world, right? Like in the orders of magnitude of billions, like everybody uses browsers nowadays. And obviously browsers can run code. And since HTML5, they can even run code in a separate thread called web worker. It's totally separated for the main event loop. So what we need, right? What we need at the moment to be able to kind of guess what sort of coordinator we could have there is the question that we need to find. Someone that would be able to deploy code into web browsers and get results and kind of build sort of a supercomputer using browsers. And the question for that is Prod Process. So Prod Process, it's a company built from a friend of mine. It was all written in Node, and this is the reason why I'm here at the end of the day, kind of. So they have a Node module. They have a REST API. Basically, you can pick a huge task, split it into chunks, send it to Prod Process. Prod Process will send it across a couple of browsers. At the moment, they have a lot of them all around the world. You get the results back. And that's it. And you might wonder, how does it work? How is it possible that they have access to web workers running on browsers in other people's computer? And the answer is really simple. So basically they pick it up the same model that advertising companies use to make advertisement online. Basically they place a little bit of one ad in your site, and every time someone clicks on that ad, or every time that someone, watches the ad, you get some sort of revenue, the page owner. So basically what they're trying to do is a similar model, but instead of deploying ads, which are annoying, they deploy a small script that connects Prod Process. And now you have sort of control over that browser in a limited way. Of course, you can't like access files or other stuff. It's really controlled, it's really sandbox, but it means that it can run arbitrary code. So you can build any sort of program, deploy them to a lot of people using the internet and get the results back. So
you have to sign your browser for that, and then you get this.
Well, no, basically if you visit, let's say I have a website, my website is Prod Process enabled, meaning that every time you visit my website, you will get the HTML with the script tag.
It runs in my browser without me.
Yes, exactly. Well, that's a different thing. About consent or not, that's a different issue. There are many ways to solve that thing, and I'm not from Prod Process, so I'm just using them because they are cheap. They're free at the moment, so it's kind of cool. You see? But that's a different issue. They have options. They're thinking about opt-in or opt-out or having message.
So you can run jobs on the server.
Not on the server, on your computer. Basically.
Wherever, on the cloud.
Yeah, on the cloud, but a cloud made of browsers. Yeah, basically.
Wherever they run. All right. So this is what they do. It's their business model. They get money from people using visitors of your own website. They charge. They charge who needs computational power, and they pay to people who have websites. Okay, so what do we need to run stuff on Prod Process? It's quite easy and simple. So basically, first thing, we need a JavaScript program, a file with at least one function called run. which takes an argument, D, but it can be any other thing. And in this case, I'm just adding 10 to D and I return that value. So this is the only thing he has to do, take an argument and return something. Then you need a JSON file, in this case, just an array, 1 to 6. And when you send it over the crowd process, it will basically run 6 instances of that function in different browsers in parallel. One of them with 1, another one with 2, another one with 3, another one with 4, another one with 5, another one with 6. So instead of doing it sequentially, it will do it in parallel and will return something like that. So this is how it works. So how can we run ray tracing on crowd process? So first, we need a JavaScript ray tracing engine because at the end of the day, this is what we are doing. And after a quick look, I found one on GitHub from this guy who works on Facebook, and it's kind of a nice project. So I used it. Of course, I had to make some adaptations to that. First of all, his algorithm was just rendering the whole thing. It was not like, it was impossible to do something like that, to tell the algorithm just render from 0, 0. That's a little square, it would render the whole image. And I would need to kind of say, I have this whole scene, but I just want to render that piece. So that was the first thing. Another thing that I had to change on that is that that project was intention to run on a web worker, and it would return an array of integers, basically, meaning the color of those pixels, and it was not really good in terms of speed for what I wanted. So I basically converted the output to some sort of base 64, because it's binary at the end of the day, and it's better to use base 64 rather than an array of ints. So in this case, as you can see, like we have a 16 square divided image, and we are expected to have some sort of 16 times speed up by doing this thing, because they will be able to run in parallel. So basically what I did, I built a Node module that would coordinate with process the delivery and the merge of those tasks in order to build, the image again as a single picture. And I used Browserify as well to make it sure that it would run on the browsers. And I created the project. That's the GitHub URL. The project is open source. I'm not sure if that, well, yeah. I'm not sure what is the license. I think it's MIT, but I'm not sure. So now I'm going to do a short demo so that you can see how does it really work. So, first of all, I have to say, obviously this is just a proof of concept to sort of prove that it's possible to do ray tracing on top of a browser-based platform, whatever that means. So, the first thing I'm trying to show is like a comparison between running the same piece of software on your computer, basically a web worker on your computer running the rendering engine, and have it using this tracer, using crowd process. So I'm going to hit run, and we will be able to see on my computer, it's rendering image by image, because this is the way it works, right? But on this tracer, I'm rendering multiple images at the same time in a lot of nodes, and you can see the speed up that I have. So on my computer, I run like 0.06 frames per second, and I can run at 140 something using the distribution system. So as you can see, it's pretty much almost finished. I'm not sure if you want to wait for my computer, because this is only 50 frames.
That's reflecting only computer power without taking the connection into account?
No, it's taking the connection into account. You mean the network connection?
Yes.
All these results basically came from the crowd process platform.
Connection can slow down substantially.
Yeah, sure, of course. But even though in this example I'm running locally using one node and I'm running in a distributed fashion, then I can have a speed up of 100 times.
So what about if you compared it with someone running a proprietary C program that's highly optimized for ray tracing?
Sure, but I have to compare the same thing, right? I would
That's
have to.
not the same. If you're running on your own computer,
it's the
you
same
can run
algorithm.
it on JavaScript.
But it's the same algorithm. It's exactly the same thing. See what I mean?
It's still an interpreted language compared to.
Oh yeah, sure, I know. But the thing is, the cost of processing is really cheap using this instead of having a far. Well, it's. I mean, there are very many variables. Sorry, say again.
That's the trade-off you're making. But it's not comparing like with like running a JavaScript algorithm on a single computer when it's designed for this distributed system.
What do you mean?
Comparing both of those are JavaScript, right?
Yeah, both of them are JavaScript. They have the exact same source file.
You're right that, like, I presume a highly optimized C processing engine would be a lot faster, but you're getting massive parallelism being free, right?
Yeah, exactly. That's the thing. It's the massive parallelism that you can have. It's all about that. If you have like, of course, you can always optimize and you can vertically scale stuff. But in this case, it's all about like massive number of nodes available to.
So this picture is raw JavaScript. Is it 3D visualization using JavaScript?
It's a rendering engine, kind of that thing that I explained before.
Yeah.
The ray beam light tracing path thing. It's built in JavaScript as a rendering engine, and it's generating those.
Was it
images.
based on images?
No. I can show you the definition of this, so I'm going to show you a different example. This is an animation. I'm going to let it run. But for instance, you can try it yourself here. You can define your own scene. I have some templates here, but let's assume this one. So for instance, you can specify the width and height of the image. You can like toggle high definition or not. You can specify the coordinates for the camera. And then I have a plane, which has this color.
Generated picture.
Yes.
Right
totally.
inside the browser.
Exactly. In my browser and in other people's browsers on the distress side of things.
Right, so slow.
Yeah, but I suppose what the point of the benefit is that this is just an example of what you can use it for. I mean, the point is that how else can you get in theory, basically, you could scale this up to every single browser on the planet, basically, running this,
in a massive system.
But you couldn't do with a C program, and you can't get you have to build it after actually create the operating system to do that. Whereas the browser is already there. I mean,
exactly. That's the standard of the web, right? Yeah. Like I'm using the standard of the web, which is JavaScript, and I totally agree with you. For some stuff, when you really need performance, you have to go for stuff like C and assembly and stuff. But in this case, this is basically a browser, like a web-based supercomputer that can run stuff in parallel. And this is the only thing I'm trying to prove here, that it's actually possible to run something complicated like ray tracing on top of that platform.
So that means instead of outsourcing to some expensive, incredibly powerful server, I can still go to the front end and write it in JavaScript and get good performance because I can distribute it on a server computer.
Sure. It depends on the task itself.
So like if I write a mobile application, so the device is not as powerful, can I still distribute it and get much better performance?
For instance, yes. But in this case, I mean, I don't have a backend. This is a front end connected to crowd process, which is the REST API, which generates everything. I don't have a backend. It's not at all. So, I suppose what I mean is, I could do things in another way. You could create your own program running on your own computer. It doesn't have to be on a browser, like just a node module, something using crowd process and doing other stuff in parallel. For instance, you could use it for data mining. You could use it for a lot of things, right? So. Just to show you a little bit, I can specify the number of tasks that I want here. So if I pick, for instance, 100 tasks, if I hit run, it was divided in 100 pieces, and the rendering is done. And as I said, this is totally generated. I can come here, for instance, and change some color.
And can it solve the problem by data overload? Like if I push 10 megabytes to a device, it can break the device. Or
you mean process, the platform itself?
Yeah.
They have a limit to that. There's limits for each individual, because they want to make sure they don't ruin the experience of someone like visiting the website.
Right, but with that technology, if I can distribute this load over several computers, I can distribute the amount of data. Will that work with?
I think they still have to load the data. Do you know what I mean? You're trying to distribute data, you just want to load it into one place. That's the platform.
Yeah, but this platform is not the best one to distribute data. This is a good one to distribute CPU processing. You see, because I just send a script, like 14 kilobyte script, and I generate that megabyte image with that. You see, so I can send like just one file to everybody and get small pieces that all together make a huge chunk of stuff, right? So just to show you, as you were asking, that this is really general. I changed the color of the sphere, so something should change over there. I'm not sure. which part it is. Yeah, so now it's purple. So, as I said, everything is generated. All right, so.
Is every individual frame also being done in parallel?
Say again, sorry?
So if it's like 1 second, 25 frames, is those 25 frames being processed in parallel?
You mean on the animation?
Yes.
Yeah,
So-
they were processed in parallel.
Okay, so there's parallelization both in frames and in
In each
quadrants.
frame, yes, exactly.
Okay.
2 times of parallelization. That's why I can have a. I made it an animation just to prove that is because if I was just comparing images, you wouldn't see the difference that much. And if you do that with an animation, you see the difference. Yeah.
Is it possible to control limit using CPU?
For you as someone,
I use this library in my browser, yeah? No, on my site, yeah? And user get my use my site.
Sure, yeah.
But it will be weird for user if this site show just some images or news and use 100% of CPU.
Sure, yeah.
It works not slow the site speed, but it uses CPU. And if you use, for example, inside mobile phone or laptop, it will very faster use energy and battery. And user will really fast to finish use my site because it's use CPU.
Sure, yeah.
Use energies.
That's a great question. So first of all, the crowd process, the way that it works, it runs on a web worker on your browser. So first of all, it's a separate thread, meaning that it doesn't interfere with the main event loop from the website, meaning that you still have the same experience in terms of scrolling and everything is going to respond the exact same way, because the worker is just a separate thread. Then that thread loads on low priority on the CPU, meaning that if there's anything important on your computer to run, it will have priority over that thing. And secondly, at the moment it's totally disabled for mobile phones. They can detect if it's a mobile phone, they just don't deploy anything there. And if it's a laptop, at the moment that might not be possible, but it will be in the future kind of possible to understand if you're using power or not, and based on that they can, like, for instance, if you're on battery, they don't deploy anything. If you're on power, they will deploy it. So, but the thing is that, I mean, at the end of the day, this is I'm not sure what would you prefer as a user of the internet. If you would rather have an internet filled with ads that that you have to deal with that all the time, or if you would rather have just a small script on a website that it doesn't harm at all, nothing that you're doing. It's a little bit like SETI at home and all those projects, you know, that allows you to fold molecules and stuff like that. But instead of having one single project that is just helping one specific target, you're actually giving the possibility for other sorts of research and stuff like that to use, you know, your computational power. So first, well, I'm not from crowd process. This is only my view. I think I'm not against it. I don't have any problem with it. I understand that some people might have.
We won't get rid of the ads. How can it be an alternative to ads?
Well, we can use ad blocker.
Yeah, but that you can use anyway.
Well, yeah.
Like, it's not an alternative, it's just...
Sure, yeah. Well, it's a conceptual alternative. The thing is that obviously if you have the option to have ads and this thing, you'll have both. But, you know, but that's... Conceptually it's an alternative, right? So that was the kind of the drive behind the creation of this project.
Also, in regards to within large organizations, you know, I mean, there's plenty of organizations that have like, you know, 50,000 PCs, you know,
Yeah.
you know, to share and some of the large companies. You know, it makes a lot of sense at that point. In that way, to actually have, you know, massively parallel resources available to the organization.
Inside, yeah. Actually, crowd process, they're targeting that market at the moment. Basically, they are selling, you know, hosted installations inside, you know, huge companies with tons of desktops and stuff.
The only reason is that, for example, me having a blog, I just want to, you know, save some money. I can participate in this program and I can actually add the script and without letting the users know that I'm having it. Yes, actually, I'm using the viewers on my blog to generate some.
Sure, but that's up to you. You know, if you want to inform them or not, it's up to you. I mean, like.
It's like the JavaScript will just work in the background. Yes, so the user will not even be aware that there's something consuming, you know.
Sure, yeah, but you can do it yourself as well. You could have a Bitcoin miner running in your people's website and no one would know. So I understand what you mean. They're basically outsourcing that thing. But
Exactly, yeah, it's just
Do you
let
know-
users know that they're used for that.
Sure.
Or accepted, yes. It's like a static plugin, like you're aware because you're installing the plugin and you're agreeing for this.
well, in this case, as I said, I'm not from crowd process. I don't have the right questions, the answers for that. But I know that they're thinking about having opt-in or opt-out, and some sort of ways to to control the if you really want to run that or not. Which is better than ads, because with ads you can't do that. You just have to do it, and if you don't want, you have to install ad blocker, right? Yeah, go ahead.
Well, much. Is there a capability to speed that up by, for example, is every pixel calculated because on its difference? Is everything recalculated, or because in certain photographs, certain scenarios, certain pixels will be the same, so they won't change?
Yeah, but at the moment, with the algorithm that I'm using, it's not optimized for
Is
that.
there a way of kind of comparing one image with the other image and then just kind of filtering out what is not, what is the same and what is different? That would speed processing time, wouldn't it?
There's a lot of optimizations we could do, but the basic, like the rendering engine that I'm using, it's really simple, as you can see. It doesn't generate like crazy images.
It's a very richer customer experience for sure. But maybe that's something we might consider, because a lot of images sometimes when you just change a slight detail,
Sure.
90% of the image might be the same, but 5% might be different.
Sure, yeah.
Same more processing time.
But in this case, it's pixel by pixel, and completely individual. There's no way
This
to.
is just a demo. Like you demonstrate this particular algorithm, and you could use this for another algorithm which is more optimized.
Sure, yeah.
So just one more question. Could you use actually WebGL for this? Like could you, instead of using CPU, just use the GPU? That would be more effective, yeah?
Sure. At the moment, crowd process, they only have standard, JavaScript. They don't have WebGL enabled. But of course, you could use that, and you could improve massively the performance of the platform. You could use WebGL, maybe not for this particular application, but for other applications where you can rely on OpenCL or WebCL. So for parallel computing using the GPUs, yeah, of course.
Just one more question. Do you have to do any validation? Like, could there be a corruption of the data coming back from the cloud? Do you kind of trust that the data is valid, or would you need to send the same chunk to do different, twice, and just compare the results if they're exactly the same, just to be 100% certain that
Well, again, that's on a level that I'm not in, which is the crowd process level.
Okay.
I use their APIs, but I know how it works, and basically they do that. Yes, they have to, because browsers, people just stay like 5 seconds on a website.
Yeah.
So if you have something you need to calculate, they have a replication factor of 5 or something like
So
that.
if they click away from the website, close the tab, then
It's over.
it's over.
That's why they have to send the same task for like 5 different browsers. To kind of have a probability that at least one of them will answer.
But if it's killed, then they will resend it as long, and will continue as long as.
Yeah, sure. But as I said, that's on a lower level for me. I kind of understand how it works, but it's a little bit out of the scope of. So, just to finish, some problems that I found doing this thing. So, first, there's a huge problem with this, which is the network bottleneck. I'm using the Ethernet cable to make sure everything would work, because if I was using wireless, maybe my computer could win, because basically I'm sending raw data from the platform to my browser, and that bottleneck, it's really hard. So that you can have an idea, for instance, rendering the image on this tracer took like, I don't know, 10 seconds or whatever, but actually the results were already computed like within 2 seconds. But the thing is that the network is so slow that to take all that data through to my computer, it's making it slow. And why it's that? It's because at the moment there's a lack of binary data transfer between the platform and the browser. So basically I have to send a string, base64 stuff. So it's not really good, but it's what we have at the moment. So who made it? Well, it's me and Pierre, a friend of mine. He's French, I'm Portuguese. We both live in Lisbon, and we decided to make this thing, for the crack, but also because crowd process, and I can make an announcement for that. They have a contest in place, which if you make some sort of application using their platform, you can get $1,000 for free. So if you want to apply, just Google for crowd process and you will check it. All right, so what's next? some stuff that I could, or we could like improve here. Like, so we could have a better rendering engine. As you see, like that rendering engine is just like basic. We could support other formats. I'm just using that format. Like, it's a basic format that came with the, let's say, came with the rendering engine. Other thing that we could do is, instead of basically dumping the binary data to the browser, we could have a backend that actually receives all that stuff and makes the video encoding and then delivers it to the browser, so we make it really fast on the transmission. And in general, improve the data transmission if we could have some sort of binary data transfer. So, well, I think it's everything. Thank you. And